Welcome to KMIT Vista. Today in this session of second unit of AITA, we will be studying the last topic in the second unit, ant colony optimization. So, ant colony optimization. So, coming to the ant colony optimization, as we know that any optimization technique uses algorithms. So, what is an algorithm? Algorithm are the processes or optimized solutions which are used to solve a complex problem. So, always for an algorithm, a principle will be there behind an algorithm. So, it can be a natural law or it can be a natural event. This algorithm uses natural events and behavior to get the low cost and best possible solution for a complex problem. So, lot of algorithms are based on the natural behavior and they are called as meta heuristic. So, what is meant by meta heuristic? Meta heuristic is having two words. One is meta, second one is heuristic. What is meta? Meta is nothing but one level and heuristic means to find a solution. So, normally in our artificial intelligence, to optimize we use swarm intelligence or particle swarm intelligence and ant colony optimization. These are the two examples for swarm intelligence. If you want to track away using a drone, we use optimization technique. To analyze any solution, normally we use swarm intelligence. The objective of the swarm intelligence algorithm is to get the optimal solution from the behavior of the insects, ants, bees, etc. So, based on the natural behavior of the insects or the ants or the bees, there will be a swarm intelligence which gives us optimal solution. So, coming to the principle of ant colony optimization. So, we know that we see the behavior of the ant. Always ants will create some colonies. So, the technique is derived from the behavior of the ant colonies. So, ants are the social insects that live in the groups or colonies instead of living individually. So, for communication, they use pheromones. Pheromones are the chemicals secreted by the ants on the soil, and the ants from the same colony can smell them and follow the instructions. The principle behind the ant colony optimization is, so ant will secrete the chemical which is a pheromone on the soil, so the same ants of the same colonies can smell them and follow the instructions. So, to get the food, ants gets the food and it uses the shortest path available from the food source to the colony. So, now ants are going for the food, secrete the pheromones, and another ants follow these pheromones to follow the shortest route. So, since more ants use the shortest route, more concentration of the pheromone increases, so that it follows the shortest path. So, the rate of evaporation of the pheromone to the other paths will be decreased, so that most of the majority of the shortest route is detected or determined. So, let us say when we see this algorithm, the algorithm have 4 stages. The first stage have 2 paths, first path and the second path. So, we have a colony here and we have a food here. So, from the colony, the ant should travel or finds the shortest path to get the food. So, in this stage there is no pheromone in the paths and they are empty paths from the food to the ant colony. Coming to the second stage, we have ant colony and we have a food. So, first some ants pick the first path and move towards the first path, so that automatically these 4 ants will secrete the 4 pheromones and the next 4 will start from here and pass to the longest path, so that it knows about the secretes the pheromone. So, here the probability of choosing the first path and there is a probability to choose a second path. So, here we have 2 paths, so that the probability of selecting first path is equal to the second path, which is of 0.5. And next coming to the stage 3, once from the colony the ants have reached from the first part, so that all the 4 have reached early and they reach in the longest path, they reach late. So, now the ants which will follow the shortest path will react to the food first and then the pheromone concentration will be higher on this path than the other path. So, coming to the next stage 4. So, while returning from the food, the ants move towards from food to the colony. So, the ant starts moving so that they see the concentration of the pheromone on the first path is larger than the concentration of the pheromone in the second path. Here one ant is moving towards here and all other ants are moving towards here. So, the evaporation of the concentration of the pheromone is highest and here the evaporation time is lesser. That is why it has taken this as the shortest path. So, here we can see again, here we have a nest. From the nest it is searching for the food, so that it starts moving from nest to the food. So, here also from nest to the food, whenever we place a obstacle between the nest and the food, it does not know how to take the path. So, once the obstacle is detected and the pheromone is secreted by the ants, so that again they start moving towards here. In the return path, so the evaporation time of the secreted pheromone is more, that is why they have taken the pheromone concentration is more from this side, that is why they have taken the shortest path. So, the behavior of the ants are used to design the algorithm to find out the shortest path. Just we saw how ants will find out the shortest path based on the concentration and evaporation time. We can convert these conditions into our algorithm. We can consider the ant colony and the source, food source as node or the vertex of the graph and the path as the edges of the vertices. So, from this we can also build a graph diagram. So, now the concentration of the pheromone can be assumed as the weights associated to the each path. So, let us convert into mathematical way. So, here there are 2 paths P1 and P2, C1 and C2 are the weights of the pheromone concentration along the path respectively. To represent the graph G of V comma E, where V represents the vertex and E represents the edge of the graph. So, initially we see that the algorithm chooses the ith path so that the probability of choosing the path is Pi is equal to Ci by Ci plus 2, where I is equal to 1 comma 2. So P of 1, P1 is equal to C1 by C1 plus C2, P2 is equal to C2 by C1 plus C2. So if C1 is greater than C2, then the probability of choosing the path 1 is more than the path 2. If C1 is less than C2, then the path 2 will be favorable. So these two conditions are very important. To choose first particular path, always we calculate the probability. After calculating the probability of choosing the path, second is for return path. We need to find out the length of the path and the rate of the evaporation of the pheromone. Or these two factors we see the return path. The concentration of the pheromone according to the length of the path is equal to Ci is equal to Ci plus K by Li, where Li is the length of the path, K is the constant depending on the length of the path. If the path is shortest, concentration will be added to the existing pheromone concentration. Change in the concentration according to the evaporation time. Ci is the Ci is the concentration at ith path, which is equal to 1 minus V into Ci. So here the parameter V varies from 0 to 1. If V is higher, automatically the concentration will be lesser. Here in this, the probability of ith path we calculate. Second, we calculate the concentration of the pheromone and the rate of evaporation, which is nothing but Ci is equal to 1 minus V into Ci. So we can convert this ant colony optimization into an algorithm. So we write the pseudocode. Procedure of ACO, ant colony optimization. Initialize the first parameters and also the pheromones concentration. While not termination, do generate initial ant population, ant colony population. Calculate the fitness values for each ant colony. Find the optimal solution using selective methods. Update the pheromone concentration. End procedure. So this ant colony optimization is used everywhere, like traveling salesman's problem. To find the solution for traveling salesman's problem, normally we use one ACO technique which is called as ant colony optimization. This is also a sub technique of swarm intelligence. Thank you.